Hello everyone, welcome to my channel Chemistry Coach. Today we are going to discuss a core concept in chemistry that is fundamental to your exams, O-level exams, the states of matter. By the end of the session, you'll have a clear understanding of how matter behaves in different states and how changes in temperature and pressure affects these states. Let's get started. What is matter? Matter is anything that has mass and occupies space. Matter exists in three primary states: solids, liquids, and gases. Each state has distinct properties determined by the arrangement and movement of its particles. Understanding these properties helps explain why ice is solid, water is liquid, and steam is gas, even though they are all forms of same substance, water, that is H2O. Characteristics of solids. Solids have definite shape and volume. This is because their particles are closely packed in a fixed, regular movement arrangement. Think of it like a tightly packed stack of oranges in a box. The particles in solid have strong intermolecular forces, which means they are held together very firmly. They can only vibrate in their fixed positions, which is why solids have very low kinetic energy and do not flow. Examples included ice, wood, and metals. Characteristics of liquid. Liquid have a definite volume but take the shape of their container. This is because their particles are less tightly packed as compared to solids, allowing them to move around and slide past one another. The intermolecular forces in liquids are moderate, meaning they are strong enough to keep the particles together but weak enough to allow some movement. This is why solids flow and can be liquids flow, sorry. This is why liquids flows and can be poured. Example includes water, oil and milk. Characteristics of gases. Gases have no fixed shape or volume. They expand to fill the entire space available to them. The particles in the gases are far apart and move freely with very weak intermolecular forces between them. Because of this, particles have high kinetic energy, moving rapidly in all directions, and that is the reason gases are easily compressible. Examples of gases include oxygen gas, nitrogen gas, and carbon dioxide gas. Kinetic Molecular Theory. The kinetic molecular theory helps us understand the behavior of particles in different states. Freedom of movement and arrangement of particles are different for three states of matter. In solids, particles vibrate but stay in fixed position. In liquid, particles have more energy and can slide past one another. And if we talk about gases, particles have the most energy and move rapidly and randomly. This theory explains why solids are rigid, liquids flow, and gases expand to fill their container. Let's look at the comparison table to better understand these differences. Particles in a solid are closely packed, and if we talk about particles of the liquid, they slide past each other, and the particles of gases are far apart. Particles of solids arrange in a regular pattern, and if we talk about the particles of liquid, they have random arrangement, and the particle of gases also has random arrangement. Particles of solids are vibrate in place. Particles of liquid move around more freely, and particles of gases move quickly in all directions. These differences explain the unique properties of each state of matter. Interconversion of states of matter. Matter can change from one state to another through processes known as phase changes. So that process is called the phase changes. Melting, solid to liquid, like ice melting into water. Freezing, liquid to solid, like water freezing into ice. Boiling, liquid to gas, such as water turning into steam. Condensation, gas to liquid, like steam turning back into water. Sublimation, solid to gas, for example, dry ice turning directly into carbon dioxide gas without becoming liquid. This picture shows the interconversion of states of matter. This shows that the conversion of solid in liquid to liquid is the melting, and liquid to solid is the freezing. And the conversion of gas to liquid is called condensation, and liquid to gas is called evaporation. Here, the conversion of solid into gas, the conversion of solid directly into gaseous state is called sublimation, and the conversion of gas into solid state is called diffusion. So when liquids are heated, particles gain energy, they move faster and start to move faster. At a certain point, some particles have enough energy to escape from the liquid's surface. This is called evaporation. If heating continues, more particles gain enough energy to overcome intermolecular forces, leading to boiling, where the liquid turns into a gas. Similarly, when a solid is heated, its particles vibrate more strongly, eventually breaking free from their fixed position and changing into liquid, which we call melting. Effect of temperature and pressure on gas volume. So what would be the effect of temperature on volume of gas? When the temperature of a gas increases, the particles move faster and have more kinetic energy. The increased kinetic energy causes the particles to collide more frequently with greater force, pushing them further apart and pushing against their container wall. As a result, the gas expands and takes up more space. So, Higher temperature leads to increase in volume. This picture shows the effect of temperature on gas volume. So here V1 is the volume before applying temperature, but if we give the temperature, it absorbs kinetic energy and the volume increases. What would be the effect of pressure on volume of gas? When you increase the pressure on a gas, you are basically squeezing it. So increasing the pressure on a gas compresses it. The gas particles are forced closer together, reducing their volume. This principle is used in compressed gas cylinders. So higher pressure leads to decreased volume. Heating and cooling curves. Heating curve shows temperature changes of a substance as heat is added, and cooling curve shows temperature changes of a substance as it cools. So let's look at the heating curve step by step to understand how substances changes state. Initially, the substance is solid. As heat is added, the temperature rises and the particles vibrate more vigorously. At point B, the solid reaches its melting point. Here the temperature remains constant as heat energy is used to break the intermolecular bonds, changing the states from solid to liquid. Once completely melted, the substance is in the liquid state. As heating continues, the temperature of the liquid rises. At point D, the liquid reaches to its boiling point. The temperature remains constant again, as energy is used to convert the liquid into gas. After boiling, the substance becomes a gas and further heating increases its temperature. This graph shows the cooling curve. The substance starts as a gas. As it cools, the temperature decreases. So at point B, the gas reaches its condensation point. The temperature stays constant as the gas condenses into a liquid. The substance is now a liquid, and as cooling continues, the temperature of the liquid decreases. At point D, the liquid reaches to its freezing point. The temperature remains constant as it freezes into solid. The substance at point E, the substance is now completely solid and further cooling reduces its temperature. Diffusion. Diffusion is a process by which particles move from an area of higher concentration to an area of low concentration. This happens quickly in gases due to high kinetic energy. When particles are in high concentration area, they collide frequently and move randomly. As they collide and exchange energy, some particles gain enough energy to break away and move from high concentration area to low concentration area. This continuous collision and motion causes the particles to spread out until they evenly distributed that complete the process of diffusion. The rate of diffusion depends on the molecular mass of a gas. Lighter gases, such as hydrogen, diffuse faster than heavier gases like carbon dioxide. Because gases with low molecular mass have a higher average kinetic energy at given temperature, causing them to move faster. For example, hydrogen gas with a relative molecular mass of 2 will diffuse much faster than carbon dioxide gas with a relative molecular mass of 44. I hope this presentation has helped you understand the fascinating concept of the states of matter and their properties. Understanding these basics is key to mastering chemistry. Don't forget to like this video, share it with your friends and subscribe to my channel Chemistry Coach for more insightful lessons. Thank you for watching.